Okay, I think I'm recording now. So, first of all, I hope y'all are all doing well. Second of all, I was going back through yesterday's problem and I think I get it now. So I want to make sure that we kind of all are on the same page. This is my work from yesterday. I'm actually going to, I don't want to erase it all. So I'm just going to like cross it out so y'all don't look at it. But if you want to look back, I'm going to write in a different color on here later and explain like where I went wrong. I think that's good enough for y'all not to look at it. I know that cross out. Okay, so for part C, let's zoom in a little bit. There's going to be a lot of writing, obviously. All right, so part C. So we were working with Jane and Tarzan. I don't know if y'all remember, but Jane and Tarzan. And we want to find the swing height the rescue. All right, so I got confused yesterday because of how they drew the picture, but I think I know what's going on now, so we're gonna quickly address that. But basically, I had told y'all we have a vine here, which we all know about now, right? So here's our vine, and then at the end of the vine, we have good old Jane. Whoops, that was a very awkward leg. Though we have good old Jane and good old Tarzan. Let's make them hold hands. All right, so they're swinging there, and then we have this maximum here. All right, we know that this is 8 meters because this vine is a total length of 8 meters, right? Here's our center of mass. All right, so we know that Jane and Tarzan are going to swing up at like a specific height, basically, and we're looking for this H. Well, here we've defined 8 meters, which is also, what do I want to call this? Okay, we'll call this LV, and then we'll call this H. Whoops. We'll call this L. Sorry, guys. Okay, so we define this as L, and here's our H. So the problem that we run into here is that our center of mass is right here. So we need to figure out this, this is H equals 0 here. So we need to figure out what this length is here, or this height is here, because that's where our vine center of mass is. And we need to account for that when we do our potential energy equations. So to do that, we need to figure out this amount here, which is going to be L minus H, right? Because we've defined this whole length as L. So we need L minus H here. And then actually to get this point, because it's at the center and this is it's supposed to be a perfect diagonal, this here is L minus H over 2, basically. So once we get that, we need to figure out what this guy is here, which should be L minus H over 2, basically. And this would be H vine final. Okay, hopefully that makes a little bit more sense with how we did the math. Now that we know that, let's start writing our equations out. Whoops, that's not what I meant to do. Let's start writing our equations out. So we know that when they start swinging, they're going to have a specific inertia, so we need to account for that too. But our basic kinematics, we're going to use, as we decided yesterday, the conservation of energy equations. And what I mean by that is K initial So K naught plus U naught equals K final plus U final. So we have kinetic energy in the beginning, which is our inertia equation, right? Half I W squared plus we have a potential energy for the vine. I've told y'all before, just in case, it's always good to count for every single like potential energy, kinetic energy, etc. Zero up, then you want to make sure we count for everything. Chain of target times. All right, and then that all equals, whoops. So what happens is, just like in kinematics, when we reach our highest point, no matter where that is, if we're swinging, let's draw something out here. This is attached right here, and here's our motion. We're going up. So once we reach this highest point, our velocity in the y is going to be 0, right? We're not moving anymore at that point. Same with projectile motion, like here in the y direction, when we hit v, is you're going up, you're going up, you're going up. Acceleration is pulling you down, right? So what happens is you're slowing down, and then at one point you're going to hit 0, and your sign changes. So then you start speeding up as you come back down, because your sign has now changed. You're not working against the force of gravity anymore. You're working with it. So your sign change, same thing here. You hit a high point, your sign is going to change. Yeah, the highest point that it hits, which is the height that the swing will be at. All right, let's keep going. So we know that that's 0. So technically, if we wrote half, this good friend of ours is going to cancel out and be 0. I just wanted to address that before I forgot. And then again, we have mass of Jane times G times H. We're going to rename this H final, by the way, just so I think that's where I messed up yesterday. So I want to make sure we get those letters in correctly. Then we have mass of Tarzan times gravity times H final plus the mass of the vine times gravity times the vine's final. Am I forgetting anything? I don't think so, at least. All right, so we have that all down, if I'm not mistaken. Okay, I'm going to stare at this for a second. I think we're good. So next thing up is we're just going to start simplifying stuff. So remember here we've defined H equals 0, right? So Tarzan and Jane were down here at H equals 0 for a little bit. So thankfully these cancel out here. 0, 0. Boom. We don't have to worry about those anymore. Thank goodness. Goodbye. So now that we've simplified out our equation a little bit, let's rewrite it just so we're clean. So it would be half IW squared plus mass of the vine times gravity times the initial height of the vine equals, we have the mass of Jane. We can actually simplify this and do mass of Jane and mass of Tarzan times gravity times the final height plus the mass of the vine times gravity times the vine's final height. So we gave an equation for the vine's final height here. So let me change colors again, right here. So what we're going to do now is take this good old friend of ours and plug it in here, so we don't have to worry about it again. So let's go back and rewrite that. So let's write here first. HVF we've defined as L minus HF over 2, basically. So when we write that, L minus HF over 2, right there. All right, So before we move on, let's simplify this, right? So we have L right here minus L over 2 plus HF over 2. So this will yield L minus 2 plus HF over 2. So put that there, G and V. So we have all of that in one place. Plus mass of Jane plus mass of Tarzan, GHF. And then do a half IW squared plus mass of the vine, mass, not mass, gravity, and then the initial height. So looking at this, we want to make sure that all of our HFs are on one side. So we're going to expand this guy out and then try to get it all where it's nice and clean to where we can all see HF on that side. And then we'll move the L over 2 over. So using distributed properties, we just distribute that, and then I'm just going to write out distributed. So we're going to have half IW squared plus MVGHV naught, height of vine initial, right? This would be minus mass of the vine times gravity, L over 2, because we've moved this part over, is equal to mass of Jane plus mass of Tarzan times G times HF plus mass of vine G HF over 2. All right, hopefully y'all agree with me so far. I'm doing this correctly. Okay, we are now at this point, so let us pull out HF on the right side. So HF, we're going to get, let's write this out bigger, MJ plus MT times G plus MVG times 1/2. All right. So now that we have all of that, let me make sure I did this correctly by checking over my work because we pulled out HF. All right, that looks right. So then what we're going to do is divide by this guy so we can get HF by itself. So what's going to happen is we're going to get HF is equal to, let's rewrite everything over again, half IW squared plus MVG HV naught minus MVG L over 2 is all over MJ plus MT times G plus 1/2 MVG. All right, so now just so let's take a step back really quick, actually. Going back here really quick, we know I because we solved for it in the last part. Oops, sorry. We solved for it over here. So this IF is what we're going to use. IF from the last part. IF from part B. All right. We also have omega squared, which we found in part B as well. Somewhere maybe here, part B. All right. And then we know the mass of the vine, we know gravity, we know the height of the vine at the bottom, because remember, we're looking at the center mass. So when when the vine is right here, the center mass is right in the middle at 4 meters. So we know this. Again, we know the mass of the vine, we know G, we know this full height length, right? I did not write LV, so this is not the length. Technically, it's the length of the vine because of how it's the problem is worded. But when I put L here, it was L length of this height. All right. We know the mass of Jane. We know the mass of Tarzan. We know gravity. We know we're looking for their final, right? It's a question mark. We have the mass of the vine, gravity, and we're looking for this final again. So technically, we have all that we need. That's why we're putting everything on one side and having HF on the left. So let me see. Oh, I have my for once I have my calculator. All right. Let's plug numbers in. to double check to make sure I did this correctly, the answer should be HF equals 1.26 meters. So let me plug everything in. So the IF from last time was 9088, and then we need 0.631. Let me put this in. 88 and 0.631. Okay, so going down here, we'll go back to green. 9088, 0.631. All right, now we can plug in Chug. So let's go down here. This is what we should be getting. Just check my work. Hopefully I did it correctly. It's half 9088 times 0.631 squared plus mass of the vine, which was I think 30. Let's go back up here. Mass of the vine is 30, Tarzan is 72, and Jane is 60. Okay, let's keep every one of those in the calculator. All right, mass of the vine is 30. We know gravity is 9.8. The initial height of the vine at center of mass is 4 minus the mass of the vine, 30, times good old gravity is 9.8. Actually, this looks like it's going to be simplified. L is 8 over 2, which this will give us 4, actually. Boom. So actually, I think this cancels out. All right, that makes it easier on us. It just happened to work that way. We have 60 plus 72 times 9.8 down here. And then we have half 30 times 9.8. So let me quickly do this math. Whoops. All right, and then yep, I got it. So I got HF is equal to 1.255. I'm just writing everything out. 895,866. So yeah, it's 1.26 meters. All right, so I did this correctly. I don't know why I keep doing that, but let's make it red. Okay, so that's how you do this problem. If y'all need more explanation with center of mass issues, let me know, but there's decent work involved with this guy. It's hard to keep track of variables, but like I said, like write everything out, because if you write everything out, then you're going to be able to see where they zero out and be less prone to making mistakes. So that's it for that problem. But to recap where we messed up yesterday, I know I messed up over here in the beginning, basically. Let's see, how can I mark this? Boom, right here somewhere. Because instead of doing like this vine height we knew as 4, I actually went in and I put the wrong equation. So this is wrong because of this reason. Because we knew the initial height, and I acted like we don't, because the drawing that they had confused me, and going back and rechecking over, I realized I was kind of brain dead. So my bad. But that's where we messed up. So don't worry about what we did in this area. I just don't want to erase it because I want to show y'all that, like, hey, it's possible to confuse yourself. But yeah, this is all in the notebook that we have. The correct is here. So let's make it darker and write redo. Or maybe we should write redone. Let's do that instead. There we go. So redone. And that's all I have for you guys. If you're confused, let me know, and we can go over the problem again. Hopefully this helps. And if you guys have any other questions on our worksheets, let me know, and we can go over it in class, or I can record some extra videos on the side. Other than that, Have a great day, everyone, and take care and good luck.